In the same way customers have to pay shipping fees when they order something online, every time a retailer orders inventory, they incur in fixed order costs of placing an order. In this video, we're going to study the trade-off between order costs and inventory holding costs. To do that, we're going to present a model that allows to choose the optimal quantity that a retailer should choose to minimize total inventory costs. We're going to discuss this using an example. The example is about a wine store. John is the manager of a large specialty wine store. We're going to help him solve his inventory problem. One of John's best-selling wines is a Pinot Noir he sources directly from a local producer. John sells 10 bottles of that wine per day. Sales are regularly spaced during the year and there's no uncertainty. Each and every single day he sells 10 bottles of wine. The economics are the following. For every bottle of wine, John pays the producer $30 and he sells the wine at the retail price of $45. Every time John places an order, he has to pay the cost of the wine up front and has to pay a fixed order cost of $500 to cover the shipping cost. In every order, the maximum amount of bottles he can order is 1,200, which is the capacity of the truck. Inventory holding costs are 15% per year. This includes the financing cost as well as other direct and indirect costs. The question is, how many bottles of wine should John order every time he places an order? We're going to call this quantity Q, or order size. So far, John has been ordering a quantity of 1,200 units every time, the full truckload. So the reason he did that was because he wanted to split the fixed cost of $500 per order over as many bottles as possible, so the idea of filling the truck seemed like a good idea. Let's see if it actually was. To do that, we're going to evaluate the annual inventory-related costs. What are those costs? So there's two types of costs. The first type of cost that we are going to consider is the cost of placing orders. The second type of cost that we are going to consider is the cost of holding inventory. Let's look at the cost of placing orders first. To evaluate that, we need to know how many orders John will place per year. Because in a year, John needs 3,650 bottles, and in every order he gets 1,200 bottles, the total number of orders will be 3.04 orders per year. At $500 per order, the annual cost will be $1,521. John's policy is the one that minimizes the total ordering costs. It is not possible to order less than 3.04 times per year because it's not possible to order more than 1,200 units every time. Remember that we said that the cost of a bottle to John is $30 and that inventory holding costs were 15%. That means that the cost of holding a bottle for 1 year is going to be $4.5. This includes the cost of financing the purchase of the inventory and other related costs. So what are the total inventory holding costs? To evaluate that, we need to calculate how many bottles of wine John will have on average. The inventory for John looks as follows. He's going to start with 0 orders, he's going to place an order for Q units, and then he's going to be selling at a constant rate of 10 bottles per day. After 120 days, he will have 0 bottles in stock and he will have to order again. So we see that inventory is going to be moving between 0 and Q. On average, he's going to be half of the time above half of Q and half of the time below half of Q. So the average inventory is going to be 600. With an average inventory of 600, his holding costs are going to be $2,700 per year. Now, note that these holding costs are higher than the order cost that John had. The total costs are going to be the total ordering cost plus the total holding cost, which in this case is $4,221. Now the question is, can we do better than what John was doing? So let's think about what would happen to costs if we change the order size. Recall that the total annual costs are the total annual ordering cost plus the total annual holding cost. Let's explore what happens to each of these components as we move Q. To do that, we can use Excel or the tool we've created so that we can evaluate the new costs. So the annual ordering costs are going to be the number of orders per year times 500, and note that this declines sharply with Q. If we want to reduce ordering cost, we should choose very high Q. For the annual holding cost is Q divided by 2 times 4.5, and this increases linearly with Q. If we want to reduce holding cost, we're going to have to choose low Q. So we see there's a trade-off between the ordering and the holding costs. How can we find the point where the total cost of ordering plus holding are minimized? To do that, you can use Excel, you can use your tool, our tool, or you can use the formula that you're seeing on screen. In this case, the optimal order size is going to be 901. This optimal order size is what's called the economic order quantity. Now let's think about why we shouldn't fill the truck. The problem of filling the truck and ordering 1,200 units every time is that this order size minimizes the cost of ordering, but it does so at the expense of the holding costs. If every time we order we fill the truck, we're going to end up having too much inventory on our shelves, and remember that we have to pay holding costs for that. If every time you order capsules from Nespresso you fill the truck, you're going to minimize the cost of placing orders, but you're going to have to hold your coffee somewhere. This is costly for retailers. Now, note that the curve of the total cost is flat around the optimal point. This means that even if we made some approximations or some small mistakes, the cost of inventory are not going to change dramatically. So this formula is quite robust to small deviations in the assumptions. You can play with the tool we've created so that you can gain some insight about what would happen as you make some changes. For example, what do you think will happen to the optimal order size if ordering costs were to decrease, for example, to 250 instead of 500? This is going to make the ordering cost part less important, so we can then use a lower Q that will reduce our holding cost. In this case, Q is going to be 637. Similarly, you can use the tool to evaluate what would happen if the product was more expensive or the cost of capital was higher. In both cases, the cost of financing the purchase will increase, so you will want to use smaller order sizes. So let's recap. In this video, we have discussed the common situation where there are fixed costs of placing an order. When choosing the order size, retailers face a trade-off between ordering costs on one side and holding costs on the other. The economic order quantity is the order size that minimizes the total cost of inventory, including both ordering and holding costs. We invite you to continue to experiment with the tool and reinforce the concepts we've seen in this video.